Welcome to ionic compounds and the simple reactions that they make. First, we do a little brief review when it comes to cations and anions. So, to put some focus on cations, those are the metal ions. Okay, those are the ones that make a positive charge, and they're often metals. You don't have any non-metals or metalloids make these very often. So they're predominantly are iron, copper, zinc, and so on. Remember, how many valence electrons they lose equals their positive charge. So if something like magnesium has 2 electrons that are valence, in losing those, we know that that makes a magnesium 2+ ion. Again, aluminum, 3 valence electrons becomes 3+. Occasional polyatomic ion like ammonium makes a positive ion, but for the most part, they're not going to be cations. Anions, nonmetal, metalloids, they're trying to gain to make a total of 8, so that equals their negative charge. Example, nitrogen has 5, gains 3 to make 8, so its charge is 3 minus. Most polyatomic ions are this way. So keep those in mind as we go throughout. So when ions come together and naturally attract because one's positive and another is negative, they come together in ratios. As we saw with the ionic compounds, these are not a 1-to-1, 1-to-2 ratios. These come into large complex crystal lattices. So what we're trying to illustrate with the chemical formula is the ratio at which these bond together. We use the term crossing the charges in order to figure this out in a very simplistic manner. So I'm going to show you some examples according to these. So let's take a look. If we were to choose some random elements that were to react, like let's say lithium with its 1+ charge, and let's say nitrogen with its normal 3- charge. The charges are 1 and 3. So when I say cross the charges, I want you to cross the charge of nitrogen down to the subscript of lithium. Likewise, lithium crosses to the subscript of nitrogen, which means when they make a compound, I'm going to have lithium with its 3, that comes from the 3 in nitrogen, and 1 for nitrogen. Now we don't write the 1, so we're just going to erase that and leave it as just nitrogen. Oops, looks like I erased a little bit of my N. So this is the correct ratio at which a lithium ion and a nitride ion would come together. Other examples, let's say we had something like barium with its normal 2+, and oxygen with its 2-. Again, I want to crisscross, bring it down, crisscross, bring it down. So in the end, I should get Ba2O2. Now, this is not the lowest ratio at which this would be found. That would be, again, 1-to-1, BaO. So you just reduce it if needed. Lastly, let's look at another example. Let's say strontium with its 2+, and carbon with its 4-. So I'm going to switch colors here. So the 4 would come down for the strontium, the 2 would come down to the carbon, and so this would get me originally Sr4C2. That's not a lowest ratio. That would reduce to Sr2 carbon, strontium carbide, as we'll talk about naming a little bit later. So again, we're talking about crossing the charges in order to go from the superscript down to the subscript, and that with these, the total charge, if we were to examine that, you would see would be 0, because you would have 3 positive charges and 1 3-, which equals 0. Barium is a 2+, oxygen is a 2-, also equals 0. Strontium is 2+, and since we have 2 of them, that will be 4+, carbon is 4 minus, so that equals, 4 minus equals, again, 0. So compounds have 0 charge, and this crossing of the charges is a simple manner. If you understand that these come in ratios, you're not ever needing to show this work, but as we get more complicated, you might want to, just so you have things down correctly. Alright, so when a metal and a nonmetal react, they make an ionic compound. And to determine what the chemical formula is for that is exactly like what we were viewing before, but now we're putting this together in a chemical equation, or at least starting off with a formula equation. Now, some elements are diatomic. These are the 7 diatomic elements. You need to memorize where they're at. They almost make a 7 on the periodic table, with the tip of the 7 pointing at the 7th one, which is hydrogen. You need to know what these are in order for you to put these in going down the road. Now, looking at the formula equation, sodium has a +1 charge, or 1 plus charge, and iodine is going to have a 1 minus charge. So in order to get our correct product, we're going to cross the charges, which you see 1 and 1. So we have NaI. So we have Na plus I2 equals NaI. These are not balanced. We'll do that next. Down here we have potassium with its positive charge, and nitrogen, which makes, erase that, which makes a 3 minus charge. 3 minus charge. So in crossing the charges from the superscript down to the subscript, I have 3 of the potassiums and 1 of the nitrogens. Lastly, calcium is a 2 plus, oxygen is a 2 minus. It doesn't matter what they were before. We're looking at how these come together and the ratios at which they do. So calcium 2, O2, which you know needs to reduce down to calcium oxide, CaO. Alright, so these are the formula equations. Now, in order to get a chemical equation, it just needs to be balanced. So far, we have 1 sodium on the left, 1 on the right. 1 and 1. So that checks out. So far on the left side, I have iodine. I have 2 of those. I only have 1 of them here. So if I put a coefficient in front, I'll now have 2 iodines and 2 sodiums. It gets kind of distributed out. However, we don't change the subscripts. We just are counting how many are on the left side, how many on the right side. You can see I'm imbalanced when it comes to the sodium, so I need to put a 2 in front of there in order to have 2 sodiums. So I have 2 sodium on the left, 2 on the right, 2 iodine, 2 iodine. This is now balanced. Potassium, I see a similar conundrum over here. I have 3 on the right, and I only have 1 on the left, so I'll need to put a 3 in order to be balanced there, also for 3. Left, I have the nitrogen, 2 on the left, only 1 on the right, so I need to make that a 2. That's going to change also my sodium, my potassium, because 2 times 3 is 6. You can always go back and change that. Change that to where I would use to make 6 here, therefore make 6 here. So I have 6 potassium on the left, 6 on the right, because 2 times 3 is 6, 2 nitrogen on the left, and 2 times 1 nitrogen is 2. And this is my balanced chemical equation. Last but not least, I might have a little experience. I might see I might want to double this already to 2 to give me my 2 oxygen, because I have 2 oxygen currently on the left side. That will give me 2 calcium. In order to get 2 calcium there, I put a 2 in front to balance. These will get more challenging. We're starting off basic and then going to expand on these. But come in with any kind of questions. I'll see you soon.